Okay, so let's take a look at inheritance and relation and generalization. So we already looked at the one-to-many that we might be able to create between courses and sections. Let's look at this other relationship of users, faculty, and student. So in MongoDB, we don't fully support inheritance, unfortunately. Very much like JavaScript basically doesn't support the notion of inheritance, even though it's object-oriented and you have dot notation and you can navigate, you can embed objects instead of objects and whatnot. You don't have the full support of inheritance, right? So the way we could support inheritance is very much like we did in JPA, where we used the single table strategy, right? So we could use that same type of strategy here, where we basically use one table and we flatten the hierarchy, the inheritance hierarchy into one single table, right? Where the base class inherited all the fields from all the children, right? Up to the base class. Same thing here. Right? Instead of having separate user and faculty and student collections, we're going to take all the fields from faculty, all the fields from student, and we're going to flatten it up to the user, the base class user. So, for instance, we could insert or update certain fields to make them. For instance, we can insert Tim Berners-Lee, which I don't believe I have in there. And update them to have set the type to be faculty, since Ada and Tim Berners-Lee might be faculty. So let's do that. Let's update Ada. Let's see what we have so far. We can say, oops, did I just drop it? Oh. I didn't mean to do that. I'm sorry. Let's create Alice real quick, or Ada. And let's create, this is first name, what was it, Ada? And we have last name, Lovelace. So I guess you were paying attention. And let's have here T. Lee and Tim Burns. Okay, so we have two users, and let's play around with and make them faculty. We'll say that Ada works at is a faculty and works at 132A, and Tim works right next to her at 133B. So let's do that. So here's update. Right? And notice that now Ada is of type faculty, and the office is 132A. We'll do the same thing for Tim. There we go. So if we do a find, so db.user.find, we'll say pretty. We see that they both have specific fields that are specific to this type of user. Right? So only faculties have offices. So it's 132A and 133B. Right? So they're somewhat near each other. And if I had students, let's insert here John and Jane. And we'll insert them to be of type student, and they will have fields that are specific to students. It would make no sense to have objects that are inheriting from each other and they don't have specific fields, right? So let's see. They have the students. So we have John here, and we'll have Jane here. That they're both students. There we go. We do a find, we'll see that Ada and Tim are faculty, and John and Jane are students, and they have their own specific fields. We have John has a GPA, but Jane does not. So we could update Jane to have a GPA of 3.9. And we see there they go, right? So they're both students. And then I can treat them and make sure that I can retrieve one or the other based on that type, very much like JPA does for us, right? Where JPA does that for us automatically. Adding the D type, we did it ourselves using JDBC, of using a specific field as well. So I can retrieve all my students by using the type, right, and there they are. So there's John and Jane, or the faculty. All right, so let's look at many-to-many.